El Magazi Learning LLC introduces a new video course on cotton fiber to yarn technology and engineering. Dr. El Magazi is a professor of textile engineering with experience of over 40 years in the textile industry.
This video course expands over 40 sessions from fiber to yarn, and it covers both fundamental and practical aspects of the fiber to yarn system.
This course is a result of many years of experience with teaching the fiber to yarn conversion system, the underlying concepts and the practical aspects of the system. It is also a result of a first-hand experience with the industry. So you will see a combined issues of practical and academic or fundamental aspects. The course will cover the underlying concepts of spinning preparation, the different spinning systems. We will also discuss the different fiber characteristics, the different yarn characteristics, and these are the knowledge base. Everybody that is working in the spinning process or even the weaving process should understand these basic concepts. We will then discuss the different elements or different phases of a fiber to yarn engineering program. The fiber to yarn engineering stems from the fact that any spinner in the world would like to achieve an optimum quality cost ratio. So the fiber to yarn engineering program focuses on the fiber and the yarn conversion system and how to optimize the quality cost ratio in this system. Perhaps the best way to start this overview is to discuss the principle of the fiber to yarn conversion system, and this is a factor or an issue that all spinners are familiar with. But for some of you who are not familiar with the system is very simple in principle. What we have here is a system in which the input material is fibers and the output material is yarn. Now a yarn may be considered as a final product if we are dealing with a spinner, or an intermediate product, but in any case it will be used in further processing, weaving and knitting and the other applications. Between the fiber and the yarn, the system consists of two basic processes. The first process is the spinning preparation process, and the whole objective of this process is to produce a fiber strand. We need to understand that our input material is fibers, and the form of these fibers is a massive bulk of fibers. So we're dealing with a massive bulk as an input material, as represented in the cotton bale or the polyester bale. So the whole idea of a spinning preparation is to actually convert the massive bulk of fibers to a linear strand that resembles the yarn that we are trying to produce. And this takes place through a number of manipulation processes, where the massive bulk is manipulated through a number of operations, as we will discuss very shortly, and finally it's converted to a fiber strand or a linear fiber strand. This fiber strand is then fed to the spinning process or the yarn formation system. The starting point in any fiber to yarn conversion system is the bale of fibers, as you see here, and a typical bale mix or laydown may consist of 20 all the way to 60. I've seen 80 and 90 bales in the laydown. So we deal with a very large number of bales, and each bale has fibers of different characteristics or different fiber attributes. So the idea first is to get a cotton mix consisting of many bales, and then mix the fibers from different bales together to produce a homogeneous mix or a homogeneous fiber mix. So basically we detach or take tufts that may range in weight from about 40 grams all the way to 80 grams, and we mix these tufts together in a mixing process, as you see here. So in the mixing process, we have tufts obtained from the different bales in the laydown or the bale laydown or the cotton mix, and the idea here is to mix these different tufts together to initiate a homogeneous mix. And when I say initiation, I mean by that there are further blending and mixing processes down the chain of the spinning preparation. So as we mix these fibers together, we produce an average fiber characteristics, or what we call it the input fiber profile, representing an average of all the bales that we've used in the mix. Now after that, as you see here, the tuft size is large, and the goal in order to reduce this large tuft size down to a linear fiber strand will be to open the fibers. That's to divide and redivide the fiber tufts down to smaller size. And the key issue here is to achieve this opening process in a very gradual fashion, because we certainly do not want to damage the fibers. So the next process after mixing will be the opening process. Now during opening, we also clean the fibers. Simply any opening process in which we divide and redivide the fibers will make all the trash particles and the foreign matter in the fibers more exposed. We can then dust them off, or through some mechanical penetration we can remove those trash particles from the fibers. So after mixing, we have opening and cleaning processes. So far we've taken tufts from different bales, we mix these tufts, and then the fiber tufts goes through a progressive opening and the cleaning operations. 2 points that you need to keep in mind here. Number one, we have to apply gradual opening on the fiber tufts to avoid damaging the fibers. So the idea here is progressively and gently we open the fibers. When it comes to cleaning, we would like to have, in the initial cleaning process, remove the large trash particles. The reason for that is we certainly do not want the large trash particles in the cotton to go any further down the opening and the cleaning line, because if this happened, those trash particles, as we open the fibers, they will also be damaged, broken into smaller or fine trash particles, which will be extremely difficult to remove. So the idea here is gradual opening and cleaning. The opening has to be gradual so that a gentle action can be applied on the fibers to avoid fiber damage, and the cleaning has to be coarse in the beginning to remove the heavy trash, and as we go further down the chain of processing, we can then apply a finer opening and the cleaning so that we can finish the job of opening and the cleaning. The three processes we just mentioned, the blending, the opening, and the cleaning, are typically performed simultaneously. Anytime you try to open, that's divide or redivide the fiber tufts, the dust and trash become exposed, so simultaneously you do some form of cleaning. And as the tuft size becomes smaller, then the possibility of better blending and enhancing the blending between the different tufts increases, and as a result of that, blending is becoming much more enhanced. So opening, cleaning, blending are three functions of the initial process, the opening and the cleaning line, that are typically performed simultaneously. That is despite the fact that we have some machines that are specialized in opening, others that are specialized in cleaning, and obviously we have mixing machines. Anytime we open the fibers, we clean the fibers, and we also blend the fiber tufts. Now, the opening process continues until we reduce the tuft size dramatically down to what we call a card web. And carding, as we will learn later on, is a fine opening and the cleaning process. This is the last machine in the opening and the cleaning line. So your chance of reducing the size of the tufts end at this point here. And ideally speaking, the card web should be very thin. In fact, theoretically speaking, it should be as thin as a single fiber thickness. So this is the final opening. Once we make the fiber web, we condense it into a linear strand, or the fiber strand, which goes through a series of drafting processes in which the size of the fiber strand is further reduced and fibers are straightened and oriented along the fiber strand. So basically what we see in line of spinning preparation is blending, opening, cleaning, and attenuation of the fiber strand to form a linear fiber strand that resembles the yarn. The difference between this fiber strand and the yarn is that, number one, that fiber strand is not very strong. Number two, it has a very large number of fibers. A typical fiber strand coming from the drawing process or the carding process may have about 30 to 40 or 50,000 fibers per cross section, which is a long way from where we started here, because when we started here we have bales of cotton, a massive bulk of fibers. Each bale may have from 50 to 70 billion fibers, and you can imagine multiplying this number by the number of bales in the mix. And in addition to that, those fibers are compressed. So we're talking about a massive bulk at very high density, and what the spinning preparation does through opening and the cleaning is that it reduces the size down to only 30 to 40,000 fibers per cross section. But a typical yarn may have a number of fibers per cross section from 40 in case of very fine yarn, all the way to 700-800 fibers in coarse yarns. So we still have a long way when it comes to drafting or attenuation before we can actually make a yarn. Now the yarn is made in a spinning process or a yarn forming system. Now there is a common principle that can be applied for all the spinning systems that we have today. This common principle is based on three basic mechanisms or three basic operations. The first operation is the drafting operation. In this operation, we actually reduce the size of the fiber strand down to the desirable size or yarn size. And what we see here is a major reduction from, as I said early on, 30 to 40 or 50,000 fibers per cross-section down to the number of fibers per cross-section, which can only range from 40 in a very fine yarn to about 700-800 in the very coarse yarn. So we can see now that we have another drafting process inherent to the spinning system. Any spinning system has built-in drafting process. And we will discuss that as we talk about different spinning systems later on. But this should be the initial process in any spinning system, drafting. The second process is consolidation. After we draft the fibers, after we reduce the size of the fiber strand down to the size of the yarn, we need to add some strength or cohesion to the fiber strand, to the yarn. And this can be achieved using different mechanisms that we will discuss later on, but the most common mechanism is fiber twisting. We twist the fibers together to form the yarn and to add the strength necessary for the yarn to withstand further processing. Now, twisting is a very unique mechanism that many engineers outside the textile engineering field are not fully aware of. Twisting is just about the only binding mechanism by which you combine the different elements of the structure, meanwhile you can maintain the flexibility. Because one may wonder, why don't we just add an adhesive material or cement or glue to the fibers and we can then put them together in the yarn? The reason that we use twisting and wrapping and other mechanisms is that we need to add the strength to the fiber strand. Meanwhile, we need to maintain or preserve the flexibility that was originally in the fiber. We need to convert that flexibility to the yarn. So the yarn will become flexible and the fabric produced from the yarn will also become flexible. So drafting to reduce the size down to the desirable size of the yarn, and then consolidation to put the fibers together and to add the necessary strength to the yarn, and then finally the yarn package forming or the winding process. So in any spinning system you have to have three mechanisms. First of all, we have to have the drafting mechanism by which we reduce the size of the desired of the yarn or the fiber strand down to the desired yarn count. Second, we have to have a consolidation mechanism, and finally we have to have some way to form a package through a winding process. Now later on in this course we will discuss the different spinning systems. We will discuss the conventional ring spinning, we will discuss the rotary spinning, we will discuss the air jet spinning as well as the friction spinning, and we will go through all the details of these spinning systems in line of the fiber to yarn engineering concept. There are in general two main types of spun yarns. The first type is what we call it carded spun yarn, in which opening, cleaning and blending as well as carding or fine opening is used. Then we have one or two passes of drawing. After that we may go to another drawing process or another drafting process, or fine drafting, we call it the roving, and in this case we will be producing a ring spun yarn, meaning that after roving we will go to the ring spinning process. or we can take the drone sliver straight to the open end or rotor spinning or the air jet spinning. Now, the yarn produced by this line of processing is called carded yarns. So this is the first main type of spun yarn that we have in the market, carded spun yarns. Now there is another type which we call it combed spun yarn, and initially speaking the processes involved in making the carded yarn are the same for combed yarn. So we have opening and the cleaning and the blending, and then we have carding, and then we have one pass of drawing, after which we go through what we call it the combing process. Now a typical combing process will consist of combing preparation and combing, and we will discuss that later on the spinning preparation chapter. Now what the combing basically does, it actually upgrades the quality of the fibers. It produces a yarn strand of much higher quality than the typical carded yarn. And the way it upgrades the fiber quality is by removing short fibers, by removing nips, which are fibers that are entangled together in the fiber strand, and also by removing trash particles. So typically the combed sliver is cleaner, has better orientation and better alignment than the carded sliver. Now after the combing preparation and combing, we can then go through similar processes to the one that we discussed earlier with the carded yarns. We can either go through roving and make a ring spun combed yarn, or we can go to rotor or air jet spinning and we produce a combed rotor or combed air jet spun yarn. So this is very important to understand that we have two main types of yarns, carded yarns and combed yarns. And again, when we talk about spinning preparation, we will go over these types of yarns in more detail. But at this point, we've discussed the basic principle of the fiber to yarn conversion system. We've discussed the basic principle of any spinning system, and we briefly discussed the two main types of yarns.
Video course on fiber to yarn engineering by El Magazi Learning LLC.